Hello, in this video I'll be talking about multiplying fractions and mixed numbers. This first one here, 3/5 of 1/2. In mathematics, the word of means multiplication, like when you're reading a word problem or something like that. The word of can be replaced with multiplication. So 3/5 of 1/2 is 3/5 times 1/2. One way to model the multiplication of fractions is to use a rectangle here. So to model 3/5 times 1/2, if I split the rectangle in half like so, and shade half of the rectangle, we'll make it blue, right? So half of the rectangle is blue. And then if I cut it into fifths, and I shade 3 of the fifths, remember this was 1 of the halves, so if I shade 3 of the fifths red, so let's do that, 3 of the fifths red, this part that's double shaded, these 3 boxes, will be the numerator, so 3, and the total number of boxes, which is 10, will be the numerator. So 3/10 is going to be the answer. The rule for this is when you're multiplying fractions, the two top numbers get multiplied together and the two bottom numbers get multiplied together. So the answer is 3/10. So I'm going to do some more examples here. In example 2, we have 3/8 times 2/5. So rather than drawing out a rectangle, because this one you would have to split it up several times by the length and the width. And this one I'm just going to show you by multiplying the tops and the bottoms. 3 times 2 over 8 times 5, which is 6/40, which we'll now have to reduce, so we can divide them both by 2, and so we get 3/20 as the final answer. But one really nice thing you can do when you're multiplying fractions is to reduce before you multiply. Reduce before you multiply. What I can do is I can see that 2 and 8 have a common denominator of 2, and so if I reduce each of those by dividing them by 2, I'll get 3 times 1, right, which is 3, over 4 times 5, which is 20, and I can skip this step here. So whenever you can reduce the fractions before you actually do the multiplication, it's going to allow you to do the problem without reducing at the end. And so you'll end up calculating with smaller numbers, which is nice. Let me show you why this works. So we have 3 times 2 over 8 times 5. Now, because the way multiplication works, 3 times 2 is actually the same as 2 times 3. So it doesn't really matter whether the fractions we were multiplying were 3/8 times 2/5 or 2/8 times 3/5, right? Because the tops are going to be multiplied regardless and the bottoms are going to be multiplied regardless. So reducing that 2 and the 8 kind of diagonally there is okay because they could have been in the same fraction anyway. So as long as you reduce one of the top numbers with one of the bottom numbers, you are allowed to reduce like that, okay, when you're multiplying. So let me give you another example of that. If we had like 3/5 times 15/30, now remember that we would be multiplying 3 times 15, which is going to be fairly large, 45, and 30 times 5, or 5 times 30. Now remember, because of the property, what do we call it? What property of multiplication? Commutative property of multiplication. We know that the 3 and the 15 could be switched to 15 and 3 if we wanted. So we can reduce either up and down or diagonally. In this case, we could do either one, but we could do the 3 divided by 3 and the 30, each divided by 3. We could also do the 15 and the 5, we could divide each of them by 5, and then we will end up with 3 over 10, which is much easier than actually doing the multiplication, 45 over 150, and then having to reduce this pretty large fraction. If we divide both by 5, we would get 9 over 30, and then divide both by 3, we would eventually get 3 over 10. But it's going to be a lot easier to do this reduction here before you multiply than later when you have these large numbers. So we're definitely going to practice that tomorrow. All right, let's do another example. Now sometimes it's not just fractions that we're multiplying. Sometimes there's actually whole numbers and fractions. So like an example, this might be if you were wrapping Christmas presents and each present needed 5/6 of a yard of ribbon and you were going to wrap 9 presents. This could easily occur if you were at the ribbon store or something like that. So to multiply a fraction and a whole number, we just make the whole number a fraction. Easy way to do that, we have this 5/6, turn 9 into 9 over 1, right? Every number can be a fraction, you just put it over 1. So now we have 5 over 6 times 9 over 1. Once again, we should reduce before we do the multiplication. So these are each divisible by 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. Now we just do the multiplication. 5 times 3 on top. 2 times 1 on the bottom. So we get 15 over 2. We can actually stop here. Some people might want to turn that into a mixed number. 15 divided by 2 is 7 with 1/2 remaining. Let's do another example. In this case, we have two mixed numbers. A common mistake here is to multiply the whole numbers, get 20, and then multiply the fractions. That is a mistake. That's not going to be correct. What I find the best way to do when multiplying mixed numbers is just to turn them both into fractions right off the bat. So 10 and 1/4. Well, 10 whole numbers, when we're talking about fourths, is actually 40 fourths, right? If we wanted to turn 10 into something over 4, it would have to be 40 over 4. Well, we already have 1/4, so that we end up having 41 fourths, right? That's 10 and a fourth. And then we're going to multiply that by, if we wanted 2 and we wanted to turn 2 into fourths, that would be 8 fourths, right? So we already have 3, so 8 fourths plus 3 fourths is 11 fourths. So here is our two fractions that we're going to multiply. Now in this case, there is no reduction that can be done here. So unfortunately, we have to make a multiplication of two fairly large numbers here, 41 times 11. So we're going to get 1, we're going to get 4, 0, 1, 4. So that we end up with 451 on top over 4 times 4, which is 16 on the bottom. Now, the fact that we couldn't reduce before we multiplied here means that we also will not be able to reduce after we multiply. So we don't have to worry about looking for common denominators here that we, not common denominators, sorry, common factors here that we can reduce with. If necessary, if the problem calls for it, we do sometimes need to turn this back into a mixed number. My rule of thumb for that is if it's just a straight up calculation problem, like something like this, I would leave it as 451 over 16. I would turn it into a mixed number if it were a word problem. Okay, so for instance, if we're talking again about yards of ribbon, you know, if you told the sales clerk you needed 451/16 yards of ribbon, they would be like, what are you talking about? They would want to know in a mixed number because that makes sense in the context of the problem. So again, the rule for deciding whether to make it a mixed number or leaving it as an improper fraction is, for a calculation problem like this, leave it improper. For a ribbon problem, like something like this, being that I told you it was a problem about ribbon, you would want to turn it into a mixed number. All right. Thanks for watching. Don't forget to fill out the form.